Our aim is to design a LED glow circuit. So basically this circuit will contain an LED. We'll not be specifying we'll be only specifying the symbol layer, and the coloring or the footprint part can be chosen later also while designing the footprint part. So we can start from this point. As you can see on the right side, there is a icon named as add a symbol. Click here. There will be adding the respected components. So we can just start by searching for an LED first of all. So I hope all of you have reached till this point, and now we'll be adding an LED. So adding an LED is simple. You just search for LED, and it will come up with an option called as LED, and this will be the symbol, how the symbol will look like. So basically, this is the symbol. This is the positive uh, part, and this is the negative part of LED. And here there are multiple options that are available. So one way to proceed is to just start from this point where we can add the component, respective component. But this option is not available for all the components or all the symbols. For some symbol, KiCad provide the option of choosing the footprint from this point itself, and there is a mid option also where we just add the symbols, and then using the assign footprint option, we assign footprint to each of the components. So we'll try both the ways. So for the LED, we will be adding the footprint here only, and normally the LED that is available in market very easily is this LED, this footprint. So all of you can note down that this is the footprint that we will be uh, using for the this particular symbol of LED. So this is LED underscore THT LED D5mm. So we just click here, and there you can see this is the footprint. This is how the soldered LED will look like from the top. So these two are the pads, and these pads are basically for the soldering part. And if you want to have a look at how an LED normally look like, I can just share some photos also. So this is basically how an 5mm LED looks like. This is there are available in multiple colors also. So this is a clear LED. It may be of white color, it may be of red color or any other color. Whereas this is a uh, diffused LED where it is already dyed in red color, and it also emits red light. Similarly, multiple color LED are easily available in the market. So this footprint of 5mm is very easy to get. So let's just add this LED. So we clicked on this part, and now we click OK. So once we click OK, uh, after we have selected the LED and the footprint also, this will appear. So this is basically a symbol, and it is not placed anywhere. This is the bounding box that is like given by KiCad itself, but it is not mandatory to design in this part only. You can design in other part also, but we'll contain our schematic for now in this part only. So now we can place the LED, but if I want to rotate the LED, I can just use the shortcut R. So all of you can note it down that by using the R key on the keyboard, I can rotate the LED. The same can be done by using right click also. Once you right click, you can rotate from these options also. Both will work, but shortcuts are pretty easy to use in KiCad, and it is one of the most important feature of KiCad that we can do multiple stuff using multiple shortcuts. So now if I left click, the LED will be placed at that particular point. So let me just place the LED. But let's suppose I want to move this LED. So I can just go to the component, and I can just press M. I can just go over the component, and if I press M, it can be used to move the LED. So note it down that M key is used for the movement shortcut. I can right click and I can move it from it is not given here, but I can deselect the add symbol part by pressing escape key. Once I press escape key, I can click on the component, I can right click, and then I can use it to move the component, or we can just use the shortcut M. So is it okay till this part? Please inform. Is it okay till this part? Were you able to
Yes,
add?
yes.
Okay, okay. So we have added the LED part, and now we'll be proceeding by adding other remaining components. So let's just go to add a symbol option, and then we can search for register also. For register also, we can just search RES, and here RER and the register symbol will appear. And here also we can just add the component by sorry, we can add the footprint by clicking on the drop down arrow, and then we can select the requested footprint. So as you can see, there are multiple options available, and one of the most obvious question will be how to go about like which component footprint should be selected here. So the best way to design a PCB is by having all the components beforehand. Like that can be done by procuring the components from the local market, or from ordering it online. So once you have the component, you can physically measure it, and once you have measured the component, then it becomes easy to assign footprint also. So that is one way of selecting the footprint. Another way is to gain some, like, at this point of time it will be difficult for all of you to select a particular footprint, but I can just list some of the footprints which are easily available and which are also heavily used in the industry. So that makes their availability in local market also easy. So you can easily get them from the local market also. So here we are planning to use all through hole components only, no SMD components. So basically, components come in two footprints. There is a SMD component which stands for surface mount device, and there is a THT or through hole component. So I can show some photos also regarding the same. As you saw that this is a LED, but the LED is inserted from the top side of the PCB, and then it is soldered on the bottom side. So just to show you, I can grab some other photos also. So as you can see the image on the right side, so the left two components are actually surface mount components. So they are soldered on the same surface on which they are mounted. So if they are mounted on the top side, they will be soldered on the top side itself. As you can see, this is a cross section of a register, which is SMD register. So it will be placed on the top side only, and it will be soldered on the top side only. But for through hole components, they are inserted from the top side, but they are soldered on the bottom side only. Normally, we soldered them on the bottom side only. So this is a difference between a through hole component and an SMD component. And now we are looking for the footprint that we'll be using for the register. So for register part, we can do one thing. We can there are multiple options available. So for this part, we are planning to use this footprint. As you can see, the name of the footprint is axial DIN 0207, L 6.3, D 2.5, and P 7.62 mm. So all the notations have a meaning here. So I can just make a note of all the meaning also. Let me just insert it first. So to get the properties of any component, you can just go on the component and press E. So E is a shortcut for properties, or you can just right click on the component and look for the properties. So as you can see, this is the name of our component, and I can just add some details also for that. So this was the name of our component, and this DIM0207 actually means that the dia of the resistor is 2 mm, whereas the length of the resistor is 7 mm. So this is also defined here itself, that length, specifically this is a class of resistance where diameter will be approximately 2 mm and resistor will be, the length of the resistor will be 7 mm. And it is also defined here itself that the length of the resistor is 6.3 mm, the dia of the resistance is 2.5 mm, which is approximately nearly 2 mm itself, and the pitch of the resistor, which is defined by P, it is the point uh, of the soldering part of the resistor. So let me just show. So as you can see here, this is the photo of a soldered resistor, and this is the body of the resistance. It is cylindrical in shape. So the dia of this resistor is 2 mm. Effectively, the length of the body between these two points, point here and point here, is 7 mm or 6.3 mm, and the point distance between the soldered point from this point to this point is 7 point, the value that was mentioned here, 7.62 mm. So this is the definition of the value that was given in the footprint option. So pitch basically is the distance between the soldering pads. So ultimately a resistance will be soldered. So this is the distance between the soldering points. So now we have added the resistance also, and now we will be adding a connector also, and that connector will be used to input power. So basically we will be using DC voltage here, and for DC voltage there is a ground voltage which is the reference voltage, and then there is a notated voltage which is either 5 volt, 3.3 volt or 12 volt. For example, you must have observed that the Wi-Fi router in the home contains a powering adapter with itself, and that powering adapter actually provides a DC voltage, because normally all the electronic part, whether it is in the LED TV, whether it is in the CPU, or whether it is in a TV remote also, all of them actually work at lower DC voltages. So it can be either 5 volt, it can be 12 volt, 3.3 volt, and so forth. So basically we will be now be adding a component which will be a connector, and that connector will be used to input power into your PCB or the circuit board, because ultimately, for example, even a TV remote requires some powering batteries, and that powering battery cannot just be connected to the circuitry. It requires some kind of connector, and that connector, here we will be using some different kind of connector, but which is easily available in the market. So we'll be just be adding a symbol. So we will search for CONN here, and in this case we will select this option. So as you can see, this is the option that we are going to choose. and we will specify the footprint later. So just double click here, and this is the connector part, and this connector part will be used to power the circuit. And since this connector gets the power from outside directly, and we don't want the LED to be turned on all the time. We want to control the power on time of the LED also. So we can do that by adding a push button or a slide switch. So normally a push button. So normally this is how a push button will look like. This is a 10xx push button that we normally use, or the name is B3F also, that we normally use. So this is a 6 mm, sorry, this is a 6 mm push button, and this bigger size is 12 mm push button that we normally use in the industry, or that is easily available, and this is through all also. So similar push button can be added. Another thing that can be added is slide switch. So this is a slide switch that can be added, and if we move it from one point to other point, basically it has 3 pins which are electrically connected, and these two are just for the supporting part. So this there is a central pin which can either be connected to the left pin, or it can either be connected to the right pin. So just by sliding it from one point to another, we can make the circuit, or we can break the connection of the circuit. So I hope it is clear till this point.
Yes, sir.
Okay, so we can either choose this part, or we can either choose that part. So we can divide it in the class itself. So 50% of the students can go for this slide switch, and other half of the students can go for the push button. This push button that I shared earlier. I will add the symbol and the footprint of both the part, so that you can choose easily. So let's just start by adding the push button first. So you can either search for button. So in the switch library, if you scroll down, you will be able to see a option which says Omron V3 FS 6x6 single pole normally open tactile switch. So, but here the issue is that this is a SMD component, not a through hole component. So we will go for this option, SW push, and there is another option, this option. So this is normally the push button that is available, and it contains of 4 pins actually. So this is a normal condition where the push button is not pressed. So pin number 1 and pin number 2 are not shorted. They are not connected. But inherently, pin number 1 and pin number 3 are shorted. They are always shorted because of the internal connection or internal construction of the push button. So pin number 1 and pin number 3 are shorted by default. Similarly, pin number 2 and pin number 4 are also default, like default, they are shorted. But when we push the press, or we press the button, pin number 1 and 2 get shorted. Similarly, pin number 3 and 4 get shorted, or all of these pins get shorted to each other. So here it is not showing any footprint option, but we will add the footprint later. So we will just press OK here, and once we press OK, we can add this push button also. Now I will be moving this component further because I want to add another component, which is the slide switch. So for moving a lot of component, you can just do one thing. Uh, Doing the left click on the mouse, you can drag, and you can then select multiple components. And once you select multiple component, you can press M to move the components together. So we have now added most of the component. Just this part is missing. We'll be adding a slide switch also. So we can go again and we can search for SPDT. So SPDT stands for single pole double throw. So as you saw in the photo also, that there are three pins, and the middle pin is actually connected to any one of the two pins on the extreme side. So we will be using this footprint SW, this symbol SW SBDT. So this is the symbol that we will be using, and for all of you, this is a normal task that half of the student will choose this component, and another half will choose the push button. So for those student who choose the push button, once they press the push button, only then the LED will glow. And for those who choose the SPDT switch, if they slide from one point to another, the slide switch, only that part will be connected. So for rotating the part, I am just using R shortcut key R, and for moving I am using the M key. So you can either choose this push button or this SPGT. The rest of the component, the connections, I will just explain. So I hope all of you have added all these components. If there is any doubt, please inform. I can just restart the process. So all of you have added the components.
Yes, sir.
Okay. So now we'll start with the connection part, and then I will explain all other uh, functions of the KiCad also. So let's do one thing. First of all, this is a symbol that we are using. It is add a wire option that is available. We just click here, and now if we go from, as you can see, there are bubbles present on all the symbols. So this bubble is basically the contact point of that component. So if I start from one point, then I can just move the cursor to the next endpoint that we are going to make. So this is the positive point. We are considering this as the positive point, and now we'll be using it. Uh, so the pin 1 of the connector connect to the pin 2 of the SPGT slide switch, and so we can do one thing. We can make two copies here. So one is for those students, and to copy any of the components, you just select the component, and then you can press Control D. So Control D is for duplicate, and using duplicate you can make multiple copies of the same component. So here I'm planning to do one thing, that for those students who have who are planning to use SPGT slide switch, they do not add this component. They can just delete the component For deleting the component, you can just select the component and press delete key on the keyboard, or you can click on the component and then right click, and here you can see the delete option also. So this is the footprint, footprint for the students who are making the SPDT based board, and this is for the students who will be using the push button for the connection part. So now we'll be making the rest of the connections also. So as you can see, if I go nearby the connection pin of any footprint of any symbol, then this option appears, or this net option basically appears. So I can click here, and then I can go to the next point, and here it will terminate. But if I try to do it in a wrong way, let's say if I go and then I click it, then it will not terminate. Then will it can go further also. It will only terminate on these bubble point. So you have to make sure that you start them at a given point and then you end it at the bubble only, so that connections are properly made. And if you want to check whether the connections are properly made or not, there is a option here which says highlight wires and pins of a net. So if I click here and then I click on the net option, it will highlight the connected pins also. As you can see, this pin and this pin are now connected. When I highlight it, all the area will be highlighted. So this means that we have made the proper connection. So this way you can check whether connections are properly made or not. So I hope this part is clear, and now we will make the rest of the connections. So for making the connection, we can just even without selecting the add a wire option, if we go nearby the bubble, it will ask us, or it will show the symbol of net wire, and then we can go and start the placing the net part. And then there are some other options that are available in the symbol part, where as you can see, there is an option given as add a power symbol. So you just click on this option, and once you click, you can search for GND. So GND stands for ground, and this is basically the reference voltage. All the voltages are referenced from this point. So I click here, I select the symbol, and then I can add it here. And as you can see, for my cursor, full there is a full plus sign that is visible, but for your symbol it may not be visible. So we can do one thing. If I deselect it, as you can see, this kind of option is appearing for the symbol that you are for the cursor that you are using. But to get a full plus sign, you can just go and check this option. In the view option, you can go and check full window crosshairs. So you click here and then full plus sign will appear. So this will help in placing the components, because once these two bubbles are in line, then it is very easy for us to connect them using net. So now again we'll make the connections. Start by clicking here and then indicate on the on this part. So I hope it is clear till this point. Now we will be going for the add a global label option. So we click on have you completed till this point, all of you?
Yes, sir.
Okay. So now we have made the connections, and now we are going to another important tool, which is add a global label. So when we click here, and basically here labeling means that if we have two nets which are far away, but we want them to be of same signal, then we can give them the same name or same label. If we give them the same label, then those two nets will be connected, and that we can also check by using the highlight tool that we used earlier. So in this case, we will be using the label as GND in capital. So all of you add a global label, and the label name will be GND. So once you do this and you press enter, then this option will appear. And if you connect this label to this point, then this pin and this pin will be connected. Although they are not visibly connected, but since this net is also connected with ground and this pin is also connected with the ground label, then they will be automatically connected. So just to prove this, we can do one thing. We can go on the highlight wires and pins of a net, and we can then click here. And as you can see, I have just highlighted this net, but even this pin is
Excuse me,
also
sir.
highlighted. Yes.
Sir, please repeat global wala part.
Okay, okay. So I'll just repeat it. So all of you have done till this part, like you've added the ground symbol. Now we are going to add a global label option. You click on this option and then this window will appear. So once this window appears, we don't want to physically add a net and connect from this point to this pin, but that can be removed by using a global label. And here we will be using the global label as GND. So you uh, enter the name, it should be same. Like even the capital and the small letter should match. Only then the label name or labels will be connected. So this is what we have added. We click OK and then we click here. We basically connect it to that point. And then you can see if I highlight it, then this whole part will be highlighted. This means that this pin and this register endpoint are connected because they both have the same name. So this net also has been connected to the ground symbol. This also is a ground, and we can do one more thing. Even if we let's say if we rename this, or we do one thing, we just copy this label. Let's say we are copying this label. So for copying a label, you can just select the label and press Ctrl D. And then if you connect it to any of the net, then it will be the connection will be made. So we click here, and now if we check, as you can see, I am just highlighting that part, but all the other parts are also getting highlighted, which means that connections are made now. But since this is extra label and we just added it for an example, we can just delete it. We click on the label and then we click delete. So once we do that, the net will not be connected, and we can just check it using this also, that only these two parts are connected via this net, not some other parts. So I hope till this part we are clear, till the label part.
Yes, sir.
Okay, so now we move to the other symbols that we have added. So here we'll be using, so here we will be using another symbol of a, or a power symbol that is normally used in the circuit. So I told you that ground is for the reference voltage. Now we can add another voltage option here, which is VCC. So this VCC is basically the higher side of the voltage. Basically ground represents zero voltage. So VCC can be used for 5 volt, 12 volt, 3.3 volt based on the circuit requirement. So we will just search VCC and then we will add VCC here. and now we will connect the first pin of this connector to this symbol. So this part is for those students who chose the SW push dual or the push button option. As I mentioned that we'll be using two option for two sets of students. One will be having SPDT switch and one will be having a push button. So that there is a difference in the output of the two of all the students. So we have added VCC here. VCC symbol we have added. We have connected the first one. Now we can do one thing. We can just go to add global and we can use this label option and we can connect on this side. So now the connections are made. This VCC pin, as I am highlighting, other parts are also getting highlighted. So this is connected now, and for other part, we can either we can do this thing that we can draw our wire from this point till this point, and other than that, we will go for this also. And now we will be adding the ground label here or ground symbol. Both ways it will work. So we have added ground here, and we will be adding ground here also. And now if I highlight it, as you can see, other circuit labels are also getting highlighted, which are ground. So now we have made all the connections, and I hope it is clear till this point. Now we will be completing the other part of the circuit. Basically, now we'll be going toward the beautification of the circuit. So this circuit, if I share it with anyone else, he or she should also understand that what my aim is with the circuit functioning. So for example, earlier I shared some uh, this schematic with all of you, that this is the example schematic that we work on. So this is one of the schematic that we have developed. So as you can see, each block is labeled that this is a 6-pin type C connector, then this is a regulator, then what is the function of this part. So all things once labeled make it also makes the circuit look good, but more importantly it conveys the functionality of a given block. So it is important here to add particular text in the schematic so that it becomes more beautiful and more justified in terms that if anyone sees it or observes it, they may know that what is the functionality. So, but for doing that, we can just go on to this feature, which is add text. We click add text, and then we, for example, here we know that the LED that we are using is red. So we can just write red LED. So this is one option. Another option is to change the value of the components. So for changing the value of the component or giving the value of any component, we can select the component and then we can right click. In the right click option, there is an option with, so you can either go to the properties part. In the properties part, you can go here and here you can see that the value is LED. So instead of this, we can just write red LED. So this is one option that we can follow. There is some there is a shortcut also for the same. Let me just undo it. So what we are doing here is we have added the label as, so we have just added a name or text which says red LED. But if we want to change the value of the component, we can just click on the component, and when we press V on the keyboard, it will give a option of edit value field. So in this edit value field, we can just go and type red LED. So now we have put the red LED value and we will click on OK. So now this is made red LED, and for this resistance also. So this is a homework for all of you, that you will be going to calculate the rest value of this resistance. So this is a basic circuit, and based on the voltage drop and based on the voltage that you select, you can set the resistance value. And I have explained this problem to faculty persons also. So I think Vinita ma'am and Geeta ma'am can share the problem statement with the students, where we will be asking them to calculate the value of the resistance. So this is the basic problem statement. I can mention it here also, that the voltage for red LED is equal to 1.8 volt. So there is a question regarding how do you add the red LED option. So basically, for adding the red LED option, we select any of the component by left clicking on it, and then we will press V key on the keyboard. So there is a shortcut for adding a value of the component. We just press the V key and we press it, and then you can give it the name. So I can give it red LED, green LED, blue LED. So this is just for our reference. So I give it red LED name, and then I click OK on it. So coming back to the other part. So here we have the option of voltage for red LED, which is 1.8 volt. Then input voltage for circuit is equal to 5 volt, and current current for the circuit is 20 milliampere. So rest of the problem statement will be explained by the faculty person, and then we will be asking you to calculate the value of resistance. So this is the problem statement for all of you, that you have to add the you have to just calculate the value of resistance in this case. So here we are applying 5 volt, and this is a red LED with the voltage drop of 1.8 volt, and this is a resistance, and we want to set the current of the circuit at 20 milliampere. So now we will be calculating the uh, of the resistance. So this is one circuit, and this is another circuit. Uh, for those who have used SPDT, this is the circuit, and for those who use the push button, this is the circuit. For adding any other detail in the circuit, we can just use the text tool, and for drawing the boundary of any circuit, we can use this option, add connected graphic lines. So here we can do one thing, we can just start, we can draw the boundary of our block. So we have added the boundary of the block also. So I hope it is clear till this point. So let's proceed further if it is okay till this point. If you have any doubt, please ask. Shall we proceed further?
Yes, sir.
Okay, so this is the part of the symbol or the schematic part, and we have completed the schematic part in most of the sense. Now, one or two things are left. One thing that is important at this point of time is the ERC option. So ERC stands for electrical rule check. So once we click here, then there is a window that appears and it asks us for run ERC. So we click on run ERC, and now you can see there are multiple errors and warnings that are given, and you can check that what are the errors that are coming or what are the warnings that are visible in your part. So as you can see, it says symbol pin or wire end off grid. So these are warnings, and for now we will be focusing on the errors first. So as you can see, it says pin not connected. So KiCad it by itself checks this schematic, and it provides them with what can be the possible issue with the schematic, so that if by mistake we are not connecting any useful pin, or we have not made the proper net while designing the wire, then it can pinpoint the issue with the circuit. So let's go first check the error part. So in the error part, as you can see, it says pin not connected. So it was expecting some connection on these pins also, but as of now, we don't need any connections to be connected on these pins. So either we can just ignore this part, or we can do one thing. There is an option that is given here, add a no connection flag. I think all of you can see this, add a no connection flag. So we'll click here, and we will add this on these 2 points where it is highlighted that there are no connection on these pins. So I can then again go to the ERC part. I can run it. So now you can see those two errors are deleted. So basically earlier KiCad was expecting some connections on these 2 points, but when we use this X symbol, by that KiCad came to know that now there are no symbols, or there are no connections that are to be required on these points. So it just removed those errors. Now it is saying that this pin is also not connected. So I can do just one thing. I can just place this no connection symbol here also. Now if I again run the electrical rule check window, that is also there are only two errors, and this error says that input power pin not driven by any output power pins. So here it means that this was actually an this pin, the pin number one is actually a power input pin, and it was expected to be driven by any output power pin. So basically, this error is being shown because it was expected by KiCad that there was some certain part that was being followed. Uh, just wait for a minute. Hello. So as you can see, it is saying input power pin not driven by any output power pin. So basically, this was some expectation from KiCad that this pin should have been driven by any output power pin, but this is not the case, and we actually know that there is no issue with our design. So we can just ignore these two warnings for now being, and for the warning part, we can come to that also. that so these are basically this basically says that the connection started from an off-grid point, but these warnings can also be ignored. We can check from some other. So only this kind of warning is coming. So we can ignore this warning. Basically, it means that KiCad is trying to say that these points should have been on a grid point, but they are actually not on the grid point. So it is treating them as a warning. But we can ignore this part and we can just click on delete all markers. So once we click here, we click on close and our schematic is complete now. We can now move to the second part of our designing of the PCB, which will be assigning footprints. So we know that for the red LED and the resistor, we have selected appropriate footprints also. But for the SPDT switch, for the push button and for the connector, appropriate footprints have not been selected. So we can do one thing. We will just select the footprint for these three things, remaining three things also. So to do that, we click and on this option which says run footprint assignment tool. So there is a question regarding where is ERC tool. So ERC tool is given here on the second row, or you can just go to tools. Sorry, you can just go to inspect and then here is the option called as electrical rule check. So we click here and then we can just check for all the issues. So now we have the footprint assignment tool. We click here, which says run footprint assignment tool. Drill machine. So now we go to the run footprint assignment tool. Please, all of you click on this option. So I hope all of you have reached till this point. Please inform if there is any doubt. You can inform. So we are now proceeding further, and I hope all of these connects the symbols are visible in your part also. So all these options are available in your part also. So we are now proceeding further. And as you can see, this is my screen. And if I click here, the respective component in the symbol is also getting highlighted. So I know which is J1 and which is J2. And when we are going to assign the footprint part, you just click on J1 first of all. So we are now going to assign the footprint for the J1 part. In some of your schematic, J2 might not be visible, and that is because we have decided to divide the नेट ऑफ करा क्या आपने हो गया ऑन हो रहा है अभी हो रहा है. So I am back now. There was some issue with the internet. So let's just start again. My screen is visible. सारे जा रहे. So we'll start with the footprint assignment part. And in this case, as you can see, so there are some symbols that have been assigned footprint, and in some case the footprint is not assigned. So for example, J1 and J2 both are the same symbol, and they will have the same footprint also. So we are now planning to select a connector which have which is easily available in the market and which we can easily use. So normally, as you know, that your phone connect via Type C, Lightning port, or a micro connector. So those type of connectors are easily available in the market, but soldering those components is very difficult. Just for the beginning part, we don't want to introduce any complication in terms of soldering part. So we are now going to use some other kind of connectors which are through hole in nature and which are easy to use or easy to solder and work with. So for that part, we are selecting a group of connector which is called as JST. So this is the option given, that there is a connector underscore JST option, and I hope all of you have reached till this assigned footprint part. And here, as you can see, there are three options given: filter footprint list by library. Then there is another filtering option, list by pin count, and list by footprint filter defined symbols. So we have clicked on this part, footprint filter list by library. Another option is there, filter footprint list by pin count. So we can just select that also. So once we select that, the number of filtered footprints actually reduces, because now it only provide with connectors which have two pins, not one, not three, or any other value, but only those component footprint which have two pins. As you can see, this has two pins, and this has all of these as two pins. Hence, it is showing only that option. And if you want to check how your footprint will finally look like, you can just select any footprint and you can click on this option. So once you click here, it will show this window. So this is how footprint will look like. All the any option that you select, this is how the footprint will look like. So for this JST option that we have selected, we are going to use this option. As you can see, this is the option that we are going to select. So this is the library that we are planning to use. So this one, this is library which says JSTXH B2B dash XHA. So this is the library that we are planning to use. So how we reach to this library? We have first selected these two options in the footprint filter part, this one and this one, and then we search for, or we just scrolled and got into the connector underscore JST library. So once we reached there, now there are limited options that are available, and we have to choose that option which is easily available in market and that we can solder on the board also easily. So for this part, we have gone to this footprint. So if we look at the footprint also, this is how the footprint will look like. And we can just double click here. And once we double click, the footprint is selected, as you all of you can see. So if I want to copy this footprint onto this symbol also, I can just click here, right click. Once I right click, it says copy. So I copy it and then I click on another symbol that we want the same footprint for. I will just again right click here and I will click on paste. So now this J2 footprint is copied onto J1 also. So I hope it is clear till this point. So all these parts are the footprints have been added upper all these parts. Now we are going to add the footprint for rest of the parts also. So this is SW2, which says as you can see, if I click on SW2, so this is the switch that we have, and on this SW2 part we are going to select the slide switch. So for slide switch part, we can either search it this way. We can either scroll down, or we can also do one more thing which we can do by using SPDT. So we'll be using this footprint which we actually found in this button underscore switch underscore TST library. So we have clicked there, and now we have there are 6 options that are appearing. We have used this footprint here: button switch TST, SW slide, 1P 2T CK. This is our option that we are going to use. So have all of you added this footprint also?
Yes, sir.
Okay. So how is the session going? It is all clear up till this point?
Yes, sir.
Okay. So with the rest of the part, like this is another option that was pre-selected by KiCad, but as we know, this is a so For the SMD components, the pads will actually appear in red color. But for the through hole components, the pads will be visible in yellow color. So whenever you are adding components, please make sure that for all the components that you add, the pad should be in yellow color only and not in red color, because in the red color it means that this footprint is not through hole, but this footprint is SMD. So once I click here, then we can see that this is not the footprint that we want. So we can just change this footprint, and there are some other options also available. So first of all, we'll try to search using the normal method. So in this case, I think footprint can be found by deselecting this option, filter footprint list by pin count. You have to deselect it, and then you can scroll down, and then you can search for this point. Uh, we were in the footprint assignment part, so I think we didn't apply or save this, as these two were deleted, but we can just re-add them again. For this part, we had selected this option. For this part, we have changed from we don't want the SMD package. We are going to the through all option, and we are going to select this option. So please uncheck this filter footprint list by pin count option. You have to uncheck it. Only after that all these options will be available. So we click here. This is the option that is appearing, button switch, THT, SW push 6 mm. So we double click here, and then we click on apply, save schematic, and continue. You can see the footprint also. So this is how the footprint will actually appear. And this is normally and very easily available, this footprint. So we'll click on apply, save schematic, and we'll click on OK. So is it clear up till this point? All of you have added the required footprint in your schematic.
Yes, sir.
Okay. So now we click on OK. Once we click on OK, now you can see that now we'll be moving to the layout part. So for the layout part, we click here, which says open PCB in board editor. So all of you click here. So once you click here, this is an empty window, and all the footprint that we have added will now be updating this PCB layout so that all the footprint appears. So click on this option which says update PCB with changes made to schematic. Click here. So some of these options may not be visible. They have been added externally using some plugins option, but this option will be available which says update PCB with changes made to schematic. The same is also available in the tools option. Click on update PCB from schematic. Once you update it, now click on update PCB, and now click on close. So once you do that, all the footprint that you have added will appear here. So just go here, click on update PCB, then click close. So all of you have reached till this point.
Yes, sir.
Okay, so now we will be placing the components, and after the placing of the component, we'll be continuing with the routing part also. So for placement of the component, it is necessary that we also look into the schematic that how our components have been placed. So as you all of you can see that our schematic starts from the connector. Left hand side is the connector. So we will use similar kind of placement of the footprint also. So this is the J1 connector and this is the J2 connector, as all of you can see. So I will click on the component, whichever I want to move or whichever I want to select. I will select the component and then I can either right click and go to the move option, or I can just click M. So either by right clicking or by moving the component using M shortcut. So this way we can move it, and if you want to place it, we can place it also. So this placement we have done, and for another footprint placement, we can just select the footprint and we will. So we are planning to do it this way. We'll first complete the upper schematic. So J1 is on the left side. Then there is a slide switch SW2 that is visible. We can just rotate it as per our requirement. Then there is D1. So we'll place D1 next to this. So we have added the red LED part, and now we are going to place the. So I will again repeat the part. So I hope all of you were able to add the components. So for now we have just considered that we have completed the schematic part. We have assigned the footprints also. Now we are going to move to the PCB part. So click on open PCB in board editor. Now you can see this is the screen that is visible. Now we will be importing all the footprints. So we will just click on update PCB with changes made to schematic. Once this is done, click on update PCB and then click on close. So you click on close. Now all the components will be added onto the PCB layout part. So now we can do one thing. We can just take the hint of placement from our schematic. So this is our first schematic. In this case, as you can see, J1 is on the left side We'll click here and we'll rotate it this way, and we have now placed our first component. So for moving, we have just you to just select the component, press move or press M. For rotating, you can just press the key R and so on. So this is the placement of our connector J1. So there will be some placement rule also that we are going to follow. You can just note them down. So for first rule, it will be place connectors on the edges only. So the basic reason for this is that once you want to connect any external connector onto that connector, it won't be easy if it is placed in inside part of the PCB. So you must take care of that the placement of the component for specifically the connector part, they are on the edges only. Next rule that we follow is that for placing any indicator, so for indicators like LED, displays, and rest of indicators, it is important that their placement is such that they are visible from all side of the PCBs. So this is an important part, that once you are placing some LED or some other kind of component, higher height component should not be near it, because if some height component is placed nearby an LED, then there are chances that it will not be visible from all sides. So that need to be taken care of. Then there is thing called as like there will be some components which will be heat generating. So heat generating components should be uh, placed in a manner that heat dissipation is easy. So heat dissipation is easily possible. In that manner only, the generated any component which generate heat should be placed. So they can either be placed on the edge side so that they can be easily cooled, or if required, we can add some small size cooling fans also on the PCB so that they can be easily cooled. Another rule which we must follow, that sensors placement should not affect their function. So for example, if there is a component which measures the temperature, then it should not be placed near a component which itself generates very high temperature, because that will actually influence the reading of that sensor. Similarly, if we have a sensor which actually measures the ambient light, then it should not be placed near any indicator on any other source of light which is there on the board, because then it will not be measuring the ambient light in the surrounding, but it will be affected by the light generated due to the LED which was placed on the board. So that kind of thing should also be uh, taken care of. So these are some rules for placement of the components. You can either note them down or take a snapshot. So as you can see, this is the connector, then this is the slide switch that we have. So we'll be placing the slide switch first. So we have placed the slide switch also. Even this slide switch should be placed on the edge only, because approaching it uh, inside the PCB will be difficult, but if it is on the edge side, then approaching it will be easier. So we have added the slide switch now. Now we have to add the D1 LED also. So we can just move it and place it. Now there is a resistance. We have to select the resistance, press M key, and then we can move it. So as you can see, there are some smaller wires that are visible. These wires are actually green in color, as you can see, and these are basically the shortest path that is possible between the two connected pads, as you can see. So if I move this component, these wires will also move along, and these basically indicate that this is the shortest path, and this is how the track will be moving from one point to another point. And we have to make sure that there is a minimum crisscrossing between these points, because if there is minimum crisscrossing, only then the routing will be easier. Otherwise, routing will be difficult. So we have placed the components in such a manner that we are following the schematic only, that there is on the left side there is a connector, then there is a SPDT switch, then there is red LED, then there is a resistance, and then the circuit is completed. So similarly we will be adding the component for the bottom part of our schematic also. Here as you can see, there is J2, and for J2 also will be rotating it. Then there is a push button that is present. So we'll click on the push button and we'll move that also. Then there is LED. So we have now added the rest of the components, and we have also placed the rest of the components. So now there are some other parts that we need to add in the circuit, but we have to start from the schematic again. In this case, we want to place some mounting hole on the edges. For example, as you can see, that there is a footprint that I want to show you, and for that footprint also, for example, this is our finally routed board, and here as you can see on all the edges there are some holes given. So these holes are basically given so that the PCB can be placed at some higher ground by using some nuts and bolts. So by using some nuts and bolts on these holes, we can increase the height of the PCB so that the bottom side of the PCB does not touch the uh, part of the bare on the bare side of the board. So as you can see, this is the PCB, and we have added holes. These are some holes that we have added, and these holes were added basically so that we can put some screws and nuts, and we can increase the height of our PCB. That was the aim for adding these holes. So this was just some example PCB that we have made, and back to our circuit. Now we have to add some footprint again, and these sorry symbols first of all, and these symbols will be for mounting holes. So we'll search for hole here, and here you can see. So if you want to duplicate any of the symbol, you can just while you are adding the symbol, you can just press on insert key. Once you press insert, footprint will be able to add multiple copies of the same footprint. So we have added 4 mounting holes. Now we will go to the run footprint assignment tool. We'll click here, and we will check the library of mounting hole. We'll click on mounting hole library, and then we will go to the then we will go to this part which says mounting hole 3.2 mm M3. So first of all, we went to the symbol option. We search for hole option, and in the hole part we search for mounting hole. So this is the library that we are going to use. This is the symbol library, and we added all 4 holes symbol. Once we have done that, we went to the run footprint assignment tool. In that option, as you can see, there is a library with the name mounting hole. We went to that part, and in that part we have to specifically use this library footprint mounting hole 3.2 mm M3. So we select that. So I'm repeating the mounting hole part again. In this case, let's say we have not added the 4 mounting hole. We have to go first to this add symbol option. In add symbol option, we have to search for hole. In hole option, as you can see, there is a mechanical library given, and in that mechanical library, go to mounting hole. In the mounting hole part, I will just double click. I will insert it. I will again press the insert key. That will insert another copy of this symbol. Again, I will insert this, and again I will insert this. So all these 4 mounting holes are now added. So once these 4 mounting holes have been added, we can go to the footprint assignment part. We click here, and as you can see, these mounting holes don't have any footprint assigned. So we search for the library with the name mounting hole. So we click here. Then in the filtered footprint list, we go down and we check for this option. In this option, uh, once we double click, it is select for this library. So we can either left click here and copy this, and we will select these three mounting holes also, or we can do it one by one. We can paste it on all the foot on all the mounting hole option, and now we'll click on apply save schematic and continue. We will click on OK. Once this is done, now we'll go back to our layout. We'll click on update PCB with changes made to schematic. We'll click on update. We'll click on close. Now you can see these four holes are present, and they will be used to mount the screws and nuts and to increase the height of the PCB. So we have also placed the holes appropriately. Just try to match the edge of the hole with the edge of the outside component. So this is the edge of the outside component, and this is the edge of our hole. So this will be drilled, and this will be just given for the reference part. So I think it is clear up till this point. Now we will try to do one more thing. We are going to add the boundary of the PCB. So to add the boundary of the PCB, we will click on this option which says draw a line. So we will click on this option which says draw a line. Once we click on this, there is an option which says edge cut. So we'll click on edge cut. I want all of you to repeat this point. Click on draw line option, then click on edge cut part. Once this is done, you can start drawing the edge or the uh, bounding line of the PCB. So you start from one point, move to other point, then again you go to other point, then you complete the rectangular or square or whatever shape of your PCB is. Once you double click, then you can just press escape to end the drawing of the line. So now we have added the mounting holes also and some components also, and this is how our PCB will look like. Obviously we have not completed the routing part, but other than that most of the part is complete. So now just to see how our PCB will look like after we have fabricated it, all of you can try doing this thing. First of all, save your PCB, then go to view, and then go to 3D viewer. Once you click that, now you can see how your PCB will actually look like. So these are the LEDs, these are the resistance, this is the push button, and here it will be slide switch. You can plan to place it nearby on the edge also. So we can do that. We can just select the component, we can press M, and then we can move it. toward the edge side. Similarly here also. So I think it is clear up till this point. So now we'll start with the routing part. Before routing part, I want all of you to, so if your like placement of the parts or arrangement is done, so we are just making the placement in such a way that use of slide switch and use of push button is easy and also the LEDs can be observed from all the sides. So that is our first aim. We have made the placement of the component. Now we have done the placement of the mounting holes also, and then we are going to make the boundary of the PCB. So to make the boundary of the PCB, we can start from this point, draw a line. Then we have to make sure that the boundary of the PCB should be outside any component. So this hole and this JST. Only after that we can start our uh, line, and this line has to be in the edge cut layer. That is also important. So we are drawing that now. So we draw it and then we end it at the point where we have started. So once that is done, now we can just see the 3D view also by going to view and then clicking on 3D viewer. So how many of you are able to observe the 3D viewer option? So please view the 3D view of your PCB. You can just even using the left click, you can just rotate the PCB or move it as per your requirement.
Yes, sir.
So once this is done, let's move to the routing part. First of all, so all of you must know that in a given house, for the air conditioner wiring and for a TV wiring, there are two kind of wires that we use normally. So for AC wires, we use thicker wires, thicker AC wire, and for normal household load, we use thin wires of same material. That is because we want that AC will be drawing more amount of current, so it will require a thicker passage of copper to carry that amount of current. Similarly, for different voltage and different current capacity routing, we have to take care of the thickness of the copper trace also. So in this case, there will be two or three important trace width. We'll start with two only first. So for default signals, the trace width will be 16 mil or 0.016 inch. Both the values are same. It is just the difference in the unit. So mil is milli inches actually. For power signals, the trace width is equal to 24 mil or 0.024 inch. So this you have to take care of, that these two things are met. And so this is important. Then other than that, we have to also check for the via size. So basically via actually means that let's suppose I'm just going to show you the photo. So as you can see in this photo, so this is the top side of the PCB, and in the top side of the PCB, you have done the routing. But in some cases, it may not be possible to do all the routing on the top side itself. So for those cases, we have to move to the bottom layer, which is on the opposite side of the board, and then complete the routing, and then go back on the top side. I think it is clear till this point that in some cases it may not be possible to draw all the lines on single side of the board, that is on the bottom side. It will be required to do some routing on the top side also. So this is the bottom side, this is the top side of the PCB. So the through hole components are inserted from the top side and soldered on the bottom side. And SMD components can be soldered on top side also and on the bottom side also, both ways. So here via will be used to move from bottom layer to top layer and then back from top layer to bottom layer. So that will be the basic function of the via. As you can see this also. So this is a through hole via which we will be using, where we move from the top side of the PCB to the bottom side of the PCB. And via will actually look like this. On any side, via will be looking like this only. So via size I'm right now mentioning. So for via, drill size is 1 mm and the via size 2 mm. So you have to take care of these things, that what is the drill size and what is the via size. So please note these things. This is important. What is the trace width and what is the drill size and via size. Make sure that you also take care of the unit. What will be the unit? Is it clear till this point?
Yes, sir.
So now we'll move to the routing part. And also all these things that we mentioned here, we are going to tell KiCad also about this, that we are going to use these values. So there are two steps now that we have to follow. First of all, here you can do one thing. You can click on this option which says edit board setup. So click on this option, edit board setup. Once you click here, a window will open. In that option, you can see predefined sizes. in the predefined sizes option, as you can see that we are currently using the mm. These three are the units of measurement in KiCad, and currently we are using mm. So, uh, as you all of you can see that these are in mil or inches. So we have to switch to the inch option first of all. So in the inch option, we select first of all, then we again go to this option, edit board setup. In the edit board option, now we have selected the predefined sizes option. In this, we click on plus, and in the plus option, we enter 0.016. We hit enter, then we enter 0.024, and then again we hit enter. So these two width, we have informed KiCad that we can be using these two values for the track width. Is it okay till this point? So now we will move to the part where we will be defining the via size also. We'll click on OK. Once we click on OK, we'll click on mm option. In the mm option, we'll again go to edit board setup. With the edit board option, we will again go to predefined sizes. In the predefined sizes option, first of all, we'll delete this. So these two are the track width that we have set already. In the Y option, we'll click plus, and then we can click set the diameter as 2 mm and the hole is 1 mm. So this is 2 mm and this is 1 mm, and then we will click on OK. So I hope it is clear till this point how we edited the board setup. You can take a snapshot of this window also. So we'll click on OK now, and we can start the routing part. So we'll again go back to the inch setting, and as you can see that we can see that the short thin wire is moving from this point to this point. So now we can start the routing part. So to start the routing part, we'll click on route track option. Click on route tracks option, and then click on 0.024 track. As we know that this footprint is actually for the power input part, so it will contain higher voltages and higher current. So we chose to do that by using 0.024 inch setting. So to start the routing part, we can just go on to the route tracks option, and wherever we left click, the routing will start. But we also have to make sure of one more thing, that our routing layer is on the bottom. So for bottom layer selection, we have to select the BCU layer. Are all of you able to observe this? That I selected route tracks option, then I selected the track option of this, and then I selected the BCU layer. So there are two layers for routing. One is FCU, another is BCU. So we clicked on BCU, then I clicked on this option, and we started with the routing part. So all these three things should be set. Please start the routing part. I think all of you can see this, how I started. I first went to this option, route tracks. I selected the track to be this size. Then I selected the layer in which I wanted to start the routing part. So I start from this point, then other ending point is highlighted. I go to that point. Similarly, for moving from this point to this point, I just click here. So this is how we are going to make the connections. Similarly, here also we'll be making the connection. If you want to change the size of the routing, you can just go here, click on this option, and then select the lower option. But you must know that for high voltage track, it will be higher. For low voltage track or track where lower amount of current will flow, it can be on the lower side also. For the ground part, we are going to use the higher setting only. So have all of you observed this? So we start from one point and then we move to the nearest point that we are being asked for. As you can see now, it is saying unrouted one, and on the bottom side, I think all of you are able to observe that there is one unrouted track. Same can be seen here also, that there is one unrouted track. So is it clear till this point? Any doubt? I can redo the part. I hope all of you are busy in the routing part. Uh, Vinita ma'am, if you can please check and inform regarding the same. Geeta ma'am, can you please check and inform whether students are able to design the board, like route the board?
Yes, sir.
Okay. So this was one part. Now we have to switch to the via option also, that how to add via. So let's just say that I want to delete this track. So I can either select delete this by selecting only this option, only this length, because if I select another length, then this length won't be selected. So you can either delete by selecting only one length, and then I can hit delete on the keyboard, or I can do another thing. I can just select it and then I can press U on the keyboard. So U key, the U shortcut key is for selecting all the length of that track, and once I select all the length, I can delete it. So now as you can see, this wire is not connected, but I have to connect it somehow to this line. So one way of doing is that I can either move it from this point to this point, but the issue with that point will be that there might be some concern with respect to the nearness of the track to the edge. So if I, let's say, didn't delete it, this is very close to the edge. So there are chances that while fabrication, this may not be getting translated onto the board properly. So I can do one more thing. I can just keep it deleted, and I can do that by complete the routing by using the Y option. So in the Y option, we have done this kind of changes. We will select that option. Now we will start the routing part again. So to start the routing part again, we can go to the route tracks option. We will click here, and then nearby this only where no component is present, we will press V key, the shortcut key for via, or we can just click here and then we can click on the, I think it is not working that way. So we can do one thing, we can click here and then we can click on right key and then we can click on place through hole via. So by right clicking, we were able to place through hole via. So how we were able to do this, we'll go back to that again. We'll click on route tracks option. We have selected the 2 mm and 1 mm option of the via. Now we will select the start the routing from this point. Then we will click here and then we can right click here. Then we can click place through via. This place through via option. We have placed the via. Now we have to move to the top layer, because this I cannot just draw the track from this side. Then the ground and VCC signal will be shorted, because if I start drawing it, it won't let me draw this. It won't be allowed to draw me from this point. I can either go from this side or I can either go from this side, but not straight. So to change draw it straight and move it to the top layer, I will select the top option, or I can just start by clicking on the top option first of all. Then I can click on the route option. I will click here. Again, I will click nearby, and then I will right click here, and then we will click on place via. I again place the wire. So we switched from the bottom layer, we went to the top layer using this wire. We have drawn the circuit in the top layer, and now we have ended the circuit in the bottom layer again. Now we can draw the remaining circuit connection in the bottom layer itself. Wait for a minute. हेलो. हाँ. मोट उसी से फोन करना, उसी को फोन करना. मेरी तो क्लास चल रही है अभी. हाँ, बात करके देखते हैं. मेरे को बता दियो एक बार लेने से पहले, मैं उनसे पूछ लूंगा फिर. हम्म. So now we have started the routing again, and now we can just draw it straight away to that point. So now also you can see there are no unrouted tracks. Or let me just redo this process again. in a easier manner. So we have first click on route tracks. The layer that we selected is BCU only, that is the bottom copper layer. Via setting is this only. So we can do one thing. We can start the routing part. Then instead of right clicking, we can just press V. So V is for placing of via. Once we press V, then it will automatically switch to top layer. Once it has switched to top layer, again press V and then place the via again, and then you will switch to the bottom layer, and then you can connect to the bottom layer copper trace, that wherever you wanted to make the connection. So this is how we place the via. And once the routing is done, I am hopeful all of you have completed the routing, or is nearby to the completion of the routing part. So now we'll move again to the remaining part, where once this routing is complete, we will go to the show the design rule checker window. You can click here, and then you can click on run DRC. So here you can see the errors are zero. There are some warnings. So what kind of warnings are there? That the name of the hole is actually outside the PCB. So this is the line, ending line of the PCB, but the name of the hole is on the outside of the PCB. So we can do one thing. We can click here. We can click M and we can move it inside the PCB, or we can just delete it also. If we want to delete, we can just delete this name also. That is also feasible. Once again, we will check the DRC. We run it, and then we can see there are no errors and no warnings. So this is how we complete the routing part. And if you want to add any text to the PCB that you have made, for example, if you want to add your name or anything else, you can just click on add a text item. Here you can add the name. You just type the name. Then you have to select the BCU layer. That is important. Once you select it, you can place it this way. So the earlier text was wrong, because if I am looking the PCB from the top side, the bottom text should actually appear inverted. So we have to click on BCU, then we have to click on add a text item. So now we have added the text also. If I want to see the 3D image, I can just check the 3D image also. As you can see, we have drawn this jumper, or jumper on the top side, as observed here. So this is actually visible in this way. On the top side, only this track is available. All the rest of the tracks are on the bottom side. I hope it is clear till this point. And now we have reached to the end of the PCB designing. For the printing part, that or the PC fabrication part, there is one more thing left that you can do. For printing this PCB, you can go to print option. Once you go to the print option, you have to select the, let me just redo this. You have to go to the print option. Once you go to the print option, you can see there is a BCU layer available. You have to check this, and you have to check the edge cut layer only. These two layers should be selected. Scale should be 1:1. You can take a snapshot of this also. Then you can go to print preview, and as you can see, this is your PCB that you will be printing. I hope it is clear till this point. So now we have reached to the conclusion, and we have covered the schematic part, and then we have covered the layout also. So here the circuit, how the circuit will work. The circuit will be powered using a JST wire, and that JST wire will bring 5 volt. And if I connect 5 volt from this point, and if I press this button, then this LED will turn on. And if I connect 5 volt and ground to this point, and if I slide the switch in appropriate direction, then this LED will keep keep on lighting. So this is how our circuit will work. Any feedback or any other point that any of you want to discuss, please inform. So I hope all of you can now uh, have at least learned the part of PCB designing, and now we are expecting you to fabricate your first PCB and test it and debug it and run it also. So
Hello, sir.
yes, ma'am.
सर ये पुश टूल के ऊपर ये जीएनटी कहाँ से आया है ये नहीं समझ आया
ये वाया के ऊपर यहाँ पे,
हाँ सर
ये बेसिकली काइकैड नाम दिखा रहा है, ये इसका कोई मीनिंग नहीं है। वो बेसिकली जो भी वायर रन हो रहा है एक पॉइंट से दूसरे पॉइंट, हमें पता रहे कि वायर का नाम क्या है, इसलिए वो बस जो भी हमने लेबल पे नाम डाला था ना, वो नाम दिखाना चाह रहा है। वो जैसे इस लेबल पे हमने कोई नाम नहीं डाला था इस वायर पे, और वो नाम काफी लंबा भी था, तो ये इस पे नहीं दिखा पा रहा है। पर जैसे ये वायर पे भी हमने कोई नाम नहीं डाला था, उसने खुद ही नाम डाल दिया। सो इसीलिए बस ये वो दिखा रहा है, बेसिकली फीचर है उसका।
सर ये आ नहीं रहा हमारा
आप आपके में वाया ऐड नहीं हो पा रहा क्या?
यस सर
वाया मैं एक बार दोबारा ऐड करना बता देता हूँ, दोबारा कैसे ऐड होगा वाया। सो लेट सपोज मेरे को अब वाया डालना है इसमें। सो स्टार्टिंग पॉइंट ये रहेगा कि मैं राउट ट्रैक ऑप्शन सेलेक्ट करूंगा। BCU मेरी लेयर सेलेक्टेड रहने वाली है, बाकी सेटिंग्स ये दोनों रहने वाली हैं जो ऊपर लिखी हुई है। सो मैं अगर यहाँ से स्टार्ट करता हूँ तो अब 2-3 ऑप्शन राउटिंग के मेरे पास, मैं यहाँ से भी ले जा सकता हूँ, पर उसमें केस है कि एक तो ये एज के पास हो जाएगा और इस पैड के भी बहुत पास हो जाएगा। सिमिलरली मैं यहाँ से भी ले जा सकता हूँ, वो भी एक फिजिबल ऑप्शन है, उसमें कुछ शॉर्टिंग का भी इशू नहीं रहेगा। पर जस्ट टू शो केस की वाया कैसे लगाया जाता है, मैं ट्रैक को रन करूंगा, एक सिग्निफिकेंट डिस्टेंस तक रखूंगा इस वाले बॉटम ट्रैक से, और फिर वी की प्रेस कर दूंगा। सो वी की प्रेस करते ही वाया आ जाएगा बोर्ड पे। इसको मैं प्लेस करूंगा, जैसे ही प्लेस करूंगा अपने आप ही वो बॉटम से टॉप लेयर में स्विच हो जाएगा। जब वो बॉटम से टॉप लेयर में स्विच होगा, अब आप इस वाले वायर से जो ब्लू कलर में है, इससे एक ठीक ठाक डिस्टेंस के बाद वापस से वायर स्टार्ट कर सकते हैं। और जब ये हो जाएगा, उसके बाद हम इसको, मतलब अब इसको हम स्टार्ट कर सकते हैं। और कहीं भी अगर मेरे को कनेक्शन बनाना है तो मैं उससे कनेक्शन बना सकता हूँ। अब ये सारा जितना भी है ये बॉटम में है। अभी जो एक आपका डाउट है कि सर, सो वाई दीज टू होल्स आई एम एडिंग, बेसिक रीजन यही है कि हर केस में पॉसिबल नहीं होता कि सारी की सारी जो राउटिंग है वो बॉटम में ही हो जाए। कभी कभी ऐसा केस आएगा जब पूरा बॉटम भरा हुआ है या फिर बहुत सारे ट्रैक्स आ रहे हैं बीच में जिनको मैं हटा नहीं सकता। उस केस में हमें वाया ऐड करना पड़ता है। स्टार्टिंग हम एक नॉर्मल ट्रैक की तरह ही करते हैं जैसे आपने बाकी राउटिंग करी है। जहां से भी हमें स्टार्ट करना है वहां पे जाके हम वी प्रेस कर देंगे। वी प्रेस करने के बाद वाया प्लेस हो जाएगा। उसके बाद अपने आप ही वो ब्लू की जगह रेड कलर की लेयर में आ जाएगा, तो यानी कि वो अब टॉप लेयर में जा चुका है। और जैसे ही वो टॉप लेयर में जाएगा, उसके बाद आसपास के ट्रैक से सिग्निफिकेंट डिस्टेंस आने के बाद हम वापस से वी की प्रेस कर देंगे, तो वापस से एक वाया आ जाएगा। उस वाया को अभी हम लेफ्ट क्लिक करके प्लेस कर देंगे। उसके बाद वापस से हम बॉटम लेयर में आ जाएंगे। सो उसके लिए हमें कोई की प्रेस नहीं करनी है, अपने आप ही बॉटम लेयर में स्विच हो जाएगा। और जब ऐसा होगा उसके बाद हम उसकी राउटिंग को कंप्लीट कर सकते हैं। सो एनी अदर क्वेश्चन? So after the completing this part, we just have DRC part left. So we have just the DRC part left, and we can do the DRC checking by using the option given here, show design rule checker window, or we can go to inspect also. In inspect, there is an option named as design rules checker. You can click here and then you can run DRC. And if there are any errors or warning, for example, let's suppose I delete this track and then again I check the DRC part. Now it will say, if I check both errors and warning, now it will say that there is a missing connection. As you can see, there is a missing connection. It will automatically notify. And once I complete this, then the error can be removed. So these kind of errors may come if you have not completed the routing. So now the schematic routing and all the other parts are complete. If there is any other doubt, please inform.